think everything's in order. Let's get this train wreck rolling, I guess. All right. And let's do it. In 2018, Alexandria Ocasio-Cortez proposed what is now known as the New Green Deal. It is a spinoff of the original New Deal enacted by FDR, which was a reform to the economy during the Great Depression. And while the New Green Deal does aim to restructure the economy, much like FDR's New Deal, it also aims to address climate concerns. This proposition mandates that the U.S. would have to make several changes to successfully address climate change, including building a national smart power grid, updating infrastructure of the United States for a higher efficiency, and shifting the nation's power supply to 100% renewable energy by 2030, with the exclusion of nuclear power. And while the bill did not get accepted, it was recognized by Congress and the House, and it was kind of pushed off to the side and not taken seriously. And while this discussion of environmental concerns is a good thing, especially the one that was brought up within the New Green Deal, and a possible foundation was laid out by this bill, the deal itself is currently not viable. Such a program would bankrupt the country for sure, and renewable energy sources currently proposed would not be able to provide our entirety of the country with power. However, the discussion of greener energy is necessary, and it provides a way for us to plan for the future of our posterity and beyond for our planet. A few limitations, well, a single limitation for this presentation is that I won't really be discussing theoretical constructs like Dyson spheres, cold fusion, or other highly theoretical constructs due to the fact that there's not enough research to support them, and there's not enough materials or know-how to build scale models of these to prove that they actually work. So it's not really important for the discussion. A little bit of history is also required to fully understand and discuss what's going on here, and the history concerns fossil fuels. Understanding of the history of fossil fuels starts with the fossil fuels being one of the largest contenders for energy production within numerous different sectors of our industry. And for the purpose of the discussion, the history of fossil fuels is divided into two main sections: the pre-industrial and post-industrial revolution. Historically, one of the earliest known fossil fuels that we know about is coal, and we have evidence of this dating back to northeastern China in 1000 BC. Records also exist of coal being used by the Greeks to smelt copper, and from 371 to 287 BC, somewhere in there, and along with the widespread use of coal in Roman society to heat water in bathhouses. And this documentation even shows that near the end of the Middle Ages, small coal mining operations had sprung up throughout Europe, according to Newman. At this time, coal was used for mostly metalworking, basic things like smithing, making swords, horseshoes, things to that extent. And we can even see that it was used for like lime burners and breweries, and in some cases just it became used for fireplaces and houses with the convention of fire bricks for chimneys, though this was only for the wealthy people. In addition to coal, we can also see that different forms of oil were used throughout history, and according for Newman, we can see that oil was used back as far back as the 1570s for waterproofing boats, lubricating chariot wheels, adhesives, and possibly even mummification ingredients. And they even go so far as to use in the Middle Ages, this is medicines, perfumes, and as weaponry such as Greek fire. And though there's slightly less documentation for this, the Chinese are kind of seen as the early pioneers for natural gas on a commercial scale. And we can see that they use natural gas possibly to heat brine for salt production, according to Newman. And the natural gas used to heat brine can also be seen documented in the 4th century with drilling operations for this gas. As far as the post-industrial revolution goes, three different types of fuel need to really be discussed, and that is coal, oil to a much further extent than the pre-industrial revolution, and natural gas. When fossil fuels began to gain a foothold before the advent of the industrial revolution, it kind of had a slow beginning. But with the advent of the Industrial Revolution, we can see that the usage of fossil fuels exploded. And a main contributor to this would be the advent of the steam engine, which could do the work of several horses at the same time with much higher efficiency. And this caused coal usage to skyrocket because that was the main fuel to heat the water for these engines. We can also see that coal usage, with the exception of economic downturns in the 1930s and 90s, continued to increase from 1900 to 2015. And following that period of exponential increase, we can kind of see a decline in the usage of coal later on as more and more efficient and higher energy content fuels were discovered and put to use, according to Newman. Oil over time has also become a significant component in the fossil fuel field since the Industrial Revolution, and that has to do with its very, very high energy density. The first oil wells were actually drilled in Titusville, Pennsylvania in 1859, and the global oil output has increased exponentially since the implementation of this first well, according to Newman. Further innovations in the oil industry, exploration, and extraction have served to increase the rate that oil is produced, alongside technological and digital enhancements that we see today, such as turbines on newer oil rigs and ships to hold them on position, and better safety equipment and procedures, such as newer and better designed blowout preventers for rigs, which keep the rigs safe and from spilling oil into the atmosphere and into the environment. Lastly, in the Industrial Revolution, we can see that natural gas production began to increase as well, with gas lamps being used to heat streetlights in Paris and London, fueled by natural gas. However, with the invention of the Bunsen burner, natural gas production exploded even more than before because it had more of a use now instead of just being kind of a one-off thing to use in different locations. And the demand for natural gas for different implementations has increased much over time. The research conducted by the oil industry became useful for the extraction and transport of natural gases as well, with strategies such as horizontal drilling, hydraulic fracturing, more commonly known as fracking, and land pipelines, making this fuel more accessible and more transportable all at the same time. And innovations in this field have made it more easy to actually get to this fuel, such as better designed pipes, modern transport equipment to take it overseas. Now we get to the three main points of my presentation. Several blatant issues that actually come with the choices of fossil fuel for energy production. First, we can see that the continued usage of fossil fuels damage people and the environment, and this damage is imminent. Secondly, we can see that fossil fuels such as oil are extremely unstable fuel sources, and interesting careers in the oil field is declining. And lastly, we can see that there are better alternatives that presently exist due to technological advancements. Overall, the current choice for fuel energy production, though some alternatives are already being introduced, are detrimental to humanity in the long run. And here we get to the first point. Fossil fuels are detrimental overall. And we can see that conventional energy is heavily reliant on fossil fuels. And with the current global usage of fossil fuels continuing to rise, irreparable environmental and social damage is imminent. Fossil fuels themselves come in several different forms with varying effects on the environment. The two forms that I will be discussing in this part of the presentation are coal and oil. Though coal has been used for power source for many years, it does have numerous detrimental effects that have actually been discovered the more we've used it and the more the science is advanced. And we can see that coal, when burned, produces carbon monoxide, heavy metals like mercury, and sulfur dioxide. Carbon monoxide on its own can actually cause unconsciousness and death in high exposures for people, according to eph-tracking.cdc.gov. And while scientists can concur that some amount of carbon monoxide can be found naturally in the environment as a result of volcanic eruptions, lightning strikes, and forest fires, on a larger scale, it can cause more significant environmental damage than these natural causes could possibly produce. This is according to npi.gov.au. And due to the effects this actually has on greenhouse gases, carbon monoxide is known to affect global warming and climate change, which presents major concerns for the environment with further increasing usage of coal in developing countries. The heavy metals produced by coal usage, including mercury and lead, can also cause significant damage to the environment and people in the surrounding areas where coal burning facilities have actually been established and released contaminants into the atmosphere. We can see that mercury alone presents significant issues to people with causing problems with reproduction, respiration, and overall cognitive ability. And when this mercury actually gets into the environment, it can actually leach into the wildlife and return and go up the food chain to humans and when we consume it. And it does not produce very good things that happen to people. The last form of pollution produced by coal is sulfur dioxide, and this adversely affects the environment directly because sulfur dioxide is known to be a cause of acid rain. And this can cause health issues in high enough concentrations, including inflammation and irritation of the respiratory system, and can contribute to worsened heart disease, according to NPS.gov. In addition to coal, oil is also a powerhouse in the energy production market, and it's used in numerous applications such as automobiles, home heating, electricity production. And though it has many benefits, including the previously aforementioned high energy density, there are several negative effects associated with it. The burning of oil can produce harmful compounds such as nitrogen oxides and volatile organic compounds, and these both contribute to ground level ozone, which is an irritant to the lungs, according to How Does Oil Impact the Environment? In addition to these chemical compounds, the burning of oil can produce particulate matter. It can cause hazy conditions that affect visibility and contribute to asthma and chronic bronchitis. When we see that spills occur, the environment is very much affected by this, and we can see that different species of marine life are actually impaired, including fur-bearing mammals and fur-bearing mammals and the water repellency of bird feathers. Animals such as sea otters and pelicans can actually die of hypothermia due to have little or no insulation from cold water, according to How Does Oil Impact Marine Life? And in addition to causing hypothermia in these animals, oil spillage can actually cause issues with fish when oil is mixed into the water column, because fish will experience reduced growth in large livers, changes to bodily functions, and even problems reproducing when exposed to this oil. And it can cause all these fish that were actually previously aforementioned to become unsafe to eat because it'll introduce oil and all this particulate matter into humans, according to How Does Oil Impact Marine Life? In refutation of this, some might argue that the effects of oil and coal on the environment are irrelevant due to other sources of energy production already being implemented, such as liquid coal. And liquid coal could be a solution to this, to these coal burning facilities specifically, according to Treebold. Though through coal liquefaction, carbon monoxide can be stripped from the coal before it's burned through processing and making liquefied coal burn cleaner and more environmentally friendly. And this can be used to produce different types of fuel, and it would possibly have a lower price per barrel than normal oil. And in response to this, we can see that to successfully produce liquid coal or any other alternative fuel source derived from the original source, significantly more of the original material is actually needed to meet global energy needs. And we can see this because 1 ton of coal is being used to produce roughly 2 barrels of fuel, in this case, liquid coal. And the manufacturing would produce more byproducts as well as a result of this, and it would not be a very good thing for the environment at all. And further proving that for alternate energy sources should be produced that are greener. This brings us to our second point, the production issues that go along with producing fossil fuels and producing energy with these fuels. And we can see that the production of energy is highly dependent on petroleum, which is a poor choice overall due to 2 major points. Job selections in younger generations are actually shifting away from the market in favor of different professions that are higher paying and less dangerous overall. And the stability of the current system is in constant fluctuation due to interference with the market. And we can see that the petroleum industry is a mainstay. It is known to be a career choice of many people. And the number of people seeking jobs in the oil field has significantly declined. Main contributor to this is workers seeking higher paying jobs. Instead of working in the oil field and earning roughly $54,000 a year at a starting position, younger workers are pursuing jobs in fields dealing with software, data, and management, with jobs as software engineers being the most sought after, according to Renzulli. Instead of earning an oil field salary, software engineers start at roughly $98,500 a year, which is obviously a stark contrast. Another reason that these people are seeking positions in the oil industry is, aside from industries aside from petroleum is the inherent risk that actually comes with working on these oil rigs. And oil field workers face a variety of dangers at work from day to day, which could very easily injure or fatally wound them. And by far the highest risk on both onshore and offshore workers is that they must deal with the risk of fire and pressure explosions, having to do with all the drilling and high pressure equipment that they're dealing with. And petroleum itself is highly flammable, easily creating explosions from static electricity, discharge, and frictional heat on oil platforms. And there are several caustic chemicals actually used in the drilling process. And these highly volatile materials, coupled with high pressure pumps and equipment used to power the rigs, easily cause a disaster if not properly managed by operators and drillers, who are responsible for the safety of everyone on the rig when they are operating. Additionally, oil rigs utilize heavy machinery which could potentially crush or maim someone and cause them to be out of work. And there's actually a first-hand story of this offered by my own father, and he reported an incident on an offshore rig where a man was actually killed by faulty equipment due to oversight by the company repairing equipment and issues with the operator himself not understanding how the equipment worked at the time in its faulty state. Secondly, oil stability. The stability of the oil market, which is a main factor for the production of energy, has constantly been in flux since its inception. And according to graphical information provided by RussiaBatters.org, after the price of crude oil dropped significantly in 2009, the oil market reached its peak in the 21st century in 2011. And this trend continues to change over time, quite drastically at most points. The second factor contributing to treacherous stability of the oil market is worldwide disasters, such as the COVID-19 epidemic that we're currently dealing with the end of right now, hopefully. And the virus has thus far affected the market in several ways, including isolation measures that have been implemented have severely stunted airlines, while American Airlines is expected to fly roughly 20% of its domestic schedule and between 10 and 20% of its international schedule. And this massive decrease in flights leads to drastically less jet fuel and adversely affecting the oil market overall by extent. Additionally, fluctuations in the stock market affect the oil market adversely, with a decline in market sentiment concerning the health of the global economy, and projections about the future oil demand curve are falling as well, showing a decline in oil prices resulting in increased layoffs in all fields and concerning oil, according to Blakesmore. And in refutation of this, some might argue that the United States is able to stabilize its oil economy. The United States, according to some, due to the advent of fracking, is now a net exporter in the world oil markets, according to Meyer. The implementations of this newfound surplus are profound and make it possible for the United States to become energy independent, circumventing major issues with stability within production by simply producing its own petroleum. And in response to this, the United States is not currently energy independent per se. While it is true that the United States is now extracting an average of 12 to 13 billion barrels of oil per day, the country still imports massive amounts of crude oil. And we can see this on fact check. The U.S. is not fully energy independent yet. These imports are due to the country's oil facilities being configured to process heavy oil, which is crude oil, while the shale oil that has been being extracted by fracking is extracted domestically, and it doesn't work properly in our oil refineries. And on the last point, that there are higher energy efficiency sources of power that we can use. And the first example of this is solar power. We can see that development of renewable technologies that have had a higher energy efficiency and energy generation call for change in power production methods, with three mainstream technologies being solar power, wind power, and hydroelectric power. Solar power is one of the most recognized forms of renewable energy and one of the easiest renewable energy harvesters to implement. Basically, you just set them up and you let them run. As long as there's daylight, they will generate power. And this feat is accomplished by saturating the solar panels with pre-existing electric charges and making a magnetic field, promoting the promotion of electricity. As photons enter the field, the electrons that are knocked free are moved by the electric field through the frame and into wires for transmission or storage, according to Dar. The smooth implementation is due to the nature of solar panels, being that the only requirement to generate electricity is direct sunlight. Additionally, modern solar arrays can now produce energy with up to 3% overall efficiency compared to the 37% efficiency offered by fossil fuel plants. This number may seem small, but however, when taking into consideration that these plants only operate at peak efficiency with fossil fuels under specific conditions, solar arrays trump them by far, as they function at a constant efficiency when exposed to sunlight. And this makes them a prime candidate for taking the place of the current methods of production. And an example of the astounding amount of power that these are capable of generating can be seen through the International Space Station, which can generate between 84 to 120 kilowatts of electricity. And this would be enough to power more than 40 homes, according to Garcia. And though the arrays on the space station are actually quite large, taking up more than half the area of a football field, the increased efficiency in modern solar panels negates this point, because the smaller solar panels that we create are now generating more power than before when the space station was designed. The next candidate that we can see is wind power, and it is has a very high potential as a candidate, and it can take over large portions of energy production in the United States. And there are several types of turbines with varying hardware, but the basic concept of a wind turbine stays the same. Simply put, the blades of the turbine have different pressure imparted upon them, and they turn a motor with a gearbox and generate electricity through a generator, and it's run to storage. Wind power is, however, limited by the speed of wind passing through the turbine, as higher wind speeds generate exponentially more electricity until the capacity limit for the turbine is actually met, according to Lee. And this form of power production boasts anywhere from 30 to 50% of the rated power output for these turbines in ideal conditions, putting wind energy at a slight disadvantage when vast amounts of power are needed very quickly. Though, as long as the wind is actually blowing in this area and there's a steady supply of it, steady power could theoretically be generated. We can also see that the wind turbines can very well generate the same amount of electricity of thousands of solar panels at peak conditions. This method additionally has been used for thousands of years on farms and ranches, and you can see windmills being used to pump water, to grind grain, and you can see like windmills from overseas in the Netherlands, to grind grain. And the last form of energy production that we can see is hydroelectric power. And this is actually a very viable candidate because large amounts of electricity can be generated at different locations to produce this power. And it can be run off to different locations and used and stored. It is highly reliable due to the fact that rivers are constantly flowing and they do not run out of a supply of water unless something drastic happens to the environment. And these hydroelectric production is actually highly variable due to dams on these hydroelectric dams being able to open and close at the push of a button, such as the Hoover Dam, for example. And these actually have the highest energy efficiency of any of the previously discussed types, because these actually convert 90% of all available energy into electricity. And this high energy efficiency actually drastically drops the price of electricity to roughly 85 cents per kilowatt hour, which is about half the cost of nuclear power and 2/5 the cost of fossil fuel energy. A refutation of this, some might say that these modes of energy production are all have solid arguments for their implementation, each having different pros. But however, some might say that the alternative energy sources cannot replace fossil fuels entirely. This is for a few reasons. Firstly, they might say that the energy sources cannot keep up with the energy generated by the fossil fuels, and that they cannot keep up with the growing energy demand over time due to unreliability. And we can also see that the production of clean energy equipment requires the use of fossil fuels, creating a dependence on fossil fuels once again, according to Chang. And we can see in response to this that researchers state that by nearly 2050, by 2050, nearly all of global power needs, roughly 82%, could be met with renewable energy. And this statistic is derived from the increased renewable energy generation in countries around the globe, such as Germany, Spain, China, and the Philippines, and other countries preparing to follow, according to Pike. In addition to this, Pike writes that emerging economies do not need to go down a path of relying on fossil fuels. Just as many developing countries skipped landlines and went straight to cellular phones, these countries could leapfrog right into affordable clean energy. And Pike says that not only could these countries immediately buy into alternative energy, but the bases that other countries have built, along with further technological advancements, guarantees a future where alternative energy is not dependent on fossil fuels. In conclusion, the new Green Deal may not be a viable conclusion when discussing a transition to alternate energy, but the bill serves as a stark reminder that the discussion is still very much alive. Due to the detrimental effects of fossil fuels, problems with filling positions within the fossil fuel industry, and better energy sources with much better fuel efficiency becoming more viable over time, America should pursue alternative energy sources. Edgar Cervantes presents a conclusive reason to take advantage of the alternative fuels when he says, unless the sun dies, winds stop, plants die, and rivers stop running, there will always be green energy to be had. Some of these energy sources are completely free, and we will have them no matter what. Why not take advantage of them? Thank you. Please tell me the video didn't freeze.
Good job, David. I just want to kind of weigh in on it before we get started in the Q&A. I kind of want to let these folks know, David, we had some issues early on, and to David's credit, he basically scrapped his thesis about 2/3 the way through. It was in the same general area, and he started completely over. And I've had, we've had students recover before, but I've never had one recover to this extent. So David, that's a great job. You're to be commended for doing what you did. I haven't seen it pulled off like what you've done previously. So good job.
Caffeine and sleep deprivation, my two greatest weapons.
There you go. This is an interesting argument. And I use the word argument because we have two sides of this whole issue, obviously. In your opinion, are we ever going to get to the place where we replace fossil fuels with renewable energy sources?
Well, yes, I think that we can after some amount of time, just as we've transitioned from coal to from coal to gasoline and diesel per se. It's kind of just like a stepping stone throughout. Like we've gone from manpower, from mining and producing these minerals, to having machines that produce these minerals to use for us to use. You get what I'm saying?
Yeah, it makes sense. It makes sense. So is this, I guess, argument between is it a money argument? Is it a capitalism argument, or is it a pragmatic argument?
Obviously, there would be a capitalism argument within it because people would not want to switch to renewable energy for the main reason that it would cost so much less to produce electricity that they wouldn't make as much money. This is we can see in some pharmaceutical applications that drugs and things are not released because people want to make money, and it'd be a driving force behind it. But if we were to be able to sway the public and the business kind of agenda to pursue fossil fuels just for the sake of the world, then it would possibly kind of fulfill a pragmatic argument as well.
Okay.
Any more questions? I'm here all day.
Hey, David. Great job. I appreciate your tackling this controversial issue. With Mr. Lawrence's background, you did a great job if you had to redo that and everything. So thank you for doing that.
Appreciate it.
Has anyone run any statistics? We have a power plant out Highway 30 here, out by Shiro, and it runs on natural gas. Has anybody done any statistics like how many windmills would it take to replace a power plant? And in other words, is it even feasible for, and this part of you brought this up in your refutation, is it even feasible to plant windmills to replace all of the power plants? That's my first question. My second observation is I'm wondering if airplanes can ever run on electricity, because there are certain parts of our economy, our industrial base, that I don't see electricity being able to power some of these things. So, a couple of comments there.
Well, first off, I don't really know of any statistics of how many it would take to fully replace the gas burning facilities that we have, but I do feel like it would be very infeasible to do, and that would require a mesh of all the different types of technology that we have. Because of the geographical differences between so many different regions, that it would take all these types to kind of mesh together and make a successful power grid that would benefit the entire country. It would have to be done on a country-to-country basis, obviously, because different countries would have different ways they wanted to handle it. And as far as the implementation of electricity with airplanes, we can see that the U.S. military actually made, actually researched this in my spare time because I found it interesting. They've made nuclear airplanes. And while the designs are very flawed and they have a very large problem with leaking radiation in the atmosphere, not that great and ideal, with more development and time into the cooling of these reactors, which is the main issue because steam would be released through vent ports on accident. With more development of a cooling system, it could be possibly viable to actually take over the air traffic, because they've actually done tests, and these nuclear engines had enough power to get these airplanes off the ground.
Great, good answer. I appreciate that, David. Good job. Thank you.
Yes, sir. Thank you.
So, David, I have no questions. I just want to applaud you for your outstanding job at recovering.
Thank you.
Okay. Yes, because that was a bit of a shock to you when you finally came to that conclusion you were going to have to start over. And I really appreciate the fact that you stuck with it and did a phenomenal job. So thank you.
Thank you. In an ideal world, I wouldn't have had to start over because I would have listened to Mr. Lawrence to begin with, but obviously I'm stubborn and that didn't happen.
Yes, well, that's true too, Mr. Codner.
Let's not confuse that for wisdom on my part. It's age and experience, not necessarily wisdom.
Sometimes you just have to let's beat our heads against the wall and figure it out the hard way.
Well, to your credit, you came to the realization.
Yes.
You know, that's, so don't discount your part in this, because I can only carry the baton so far, so to speak. You're the one that did the heavy lifting. Yeah. Yeah. I thought this is obviously a big boy topic just because there's so much to it. For me, one of the strengths of this was the tight organization. I thought it flowed very well. If I was listening to this in a debate, it would be a very easy debate to flow and to follow and to point the arguments. And that's really what we're doing, is giving that type of structure. So I think you've done a really good job of encapsulating that. So good job on the structure.
All right.
And what I've seen just in the Q&A, once you got off script and you were able to show us the depth and the breadth of your knowledge, that's when you really kind of took off flying, so we could see really your expertise on this subject and not be bound by what you had on script, so to speak.
And I call that OCS, or only child syndrome, when you have too much spare time and not enough things to do.
Yeah, well, whatever it is, it worked.
Yeah.
If nobody else has any questions, David, you don't have to worry about rounding up a computer. You can go get out of your suit. You can go do whatever it is you want to do, and you can stop your sleepless nights because of Lawrence.
All because of Lawrence. But now it's going to be because of A&M because I have too much to do and not enough time to do it.
Well, that's what we call life.
Yeah, sounds like life. I'd like to say
All
a
right,
quick
we'll
thank
see
you to
you, bud.
Emily for actually jumping in and joining us. She decided that she wanted to come view my thesis, so I sent her the link right before. And I'm off to go get a haircut because we have senior walk tonight. So I'll see
Yeah.
you guys later.
All
Good
right.
You did a good job, David.